Welcome, AI engineers and developers. Today, we are exploring the control flow mechanisms within LangGraph. We will master the differences between direct transitions and conditional routing, a fundamental concept for upgrading static AI chains into dynamic, decision-making agents. Let's get started. Let's begin by defining how data flows in a stateful AI application. In LangGraph, your application is modeled as a graph. The nodes represent the actual workers like an LLM generating text or a Python function executing a web search. But nodes don't know what happens after they finish. That is the job of the edges. Edges act as the nervous system of your AI agent, moving the state from one processing step to the next. Why is this critical? Because without tightly controlled edges, your application is just a disjointed collection of scripts. By explicitly mapping out these pathways, you define exactly how your agent behaves. In modern AI architectures, we manage this flow using two distinct strategies: direct transitions for fixed processes and conditional routing for dynamic, agentic behavior. Look at this high-level flowchart. The circular node on the left is our application state, which feeds into node A. Once node A completes its processing, the arrow representing our edge takes over and dictates the flow, passing the updated state to node B and finally to the end. The edge is the absolute source of truth for the execution sequence. Our first focus is the direct transition, also known as a normal edge. Think of this as a train track with no switches. Once the source node finishes its task, the execution automatically, predictably, and deterministically moves to the target node. Why do we use direct transitions? They are perfect for rigid pipelines where the order of operations never changes. For example, if you are building an ETL pipeline that extracts text from a PDF, splits it into chunks, and saves it to a database, there is no need for AI decision-making between those steps. They must happen sequentially. In LangGraph, implementing this is as simple as calling the addEdge method and passing the source and target node names. This essentially replicates traditional software pipelines, providing guaranteed execution order without cognitive overhead. This sequence diagram illustrates a perfect use case for direct transitions. Execution flows rigidly from start to the extract node, down to the format node, and finally to the save node. There is no ambiguity, no alternative paths, and no logic required to figure out what happens next. The execution simply follows the predefined arrows. If direct transitions are so reliable, why move away from them? The answer is adaptability. Direct transitions are rigid. Imagine building an agent that can either search the web or calculate math. If you hardcode a direct edge from the reasoning node to the web search node, the agent will search the web even when asked to add two numbers. True AI agents require autonomy. They must evaluate the current situation and adapt their execution path in real time. Because user inputs are highly unpredictable, our systems cannot rely on fixed sequences. We need a way to insert logic gates between our nodes, gates that can inspect the application state, read the LLM's intent, and dynamically route the workflow. This crucial shift from rigid, predefined paths to dynamic decision-making is what transforms a basic automated workflow into a highly intelligent, autonomous agent. Look at the bottleneck visualized here in red. The LLM reasoning node sits at the top. If we use a static edge, we are forced down one path, like web search, completely ignoring the other valid tools like the calculator or providing a final answer. Static edges fundamentally fail when branching possibilities exist. We need a routing mechanism. To solve the branching problem, LangGraph introduces conditional routing. A conditional edge isn't just a simple connection, it is an intelligent switchboard. It relies on a custom Python function that executes right after the source node finishes. This function inspects the current graph state, for example, checking if the LLM requested a tool call or if an error flag was raised. Based on what it finds, the function returns the name of the next node to execute. Why is this so powerful? It enables complex architectures like intent-based routing, where queries are dispatched to specialized agents, or self-correction loops, where an agent can retry a failed task until it succeeds. To implement this, you use the add conditional edges method, providing the source node, your routing function, and a mapping dictionary that safely links the function's output to the exact destination node in your graph. This flowchart highlights the green conditional routing block. After the source node completes, the routing function intercepts the state. By inspecting the data, it makes a dynamic decision. If the state says tool, it routes left to execution. If it says end, it routes down to terminate. If it detects an issue, it routes right to handle the error. Total dynamic control. Let's dive into the actual Python code. First, you define your routing logic as a standard function. For instance, def route logic, state, checks the state dictionary. If it finds a flag indicating a tool is needed, it returns the string tools, otherwise, it returns end. Next, you construct your graph. You still use normal edges where appropriate, for example, builder.addEdge tools. LLM node ensures that after a tool executes, control always loops back to the LLM. But the magic happens with builder.addConditionalEdges. You specify the source as LLM node, plug in your route logic function, and finally provide a mapping dictionary. This dictionary is crucial for safety. It maps the string your function returns exactly to the internal node names of your graph. This explicit mapping prevents edge cases where an LLM might hallucinate a destination, keeping your application secure and predictable. Here we see the class interaction that powers conditional routing. The state graph builder orchestrates the workflow. At runtime, when a conditional edge triggers, the builder calls your custom routing function. The function evaluates the state and outputs a string. This string is then passed against the mapping dictionary to ensure it safely resolves to a valid target node in your architecture. Let's apply this to a real-world use case, an enterprise travel assistant. We have a system with two highly specialized agents, a travel information agent and an accommodation booking agent. When a user sends a message, we cannot use a direct edge because we don't know what they want yet. Instead, we set our entry point to a router node. This node uses a fast, lightweight LLM to simply classify the user's intent. The LLM updates the graph state with a key called destination agent, setting it to either travel info or booking. We then use a conditional edge equipped with a simple lambda function that reads that exact state key. LangGraph intercepts the state, reads the key, and flawlessly dispatches the request to the correct specialist agent. This intent-based routing pattern is the cornerstone of scalable, multi-agent systems, ensuring users always hit the right expert without hard-coding rigid paths. This state diagram maps our travel assistant scenario. The user query hits the router node first. Inside, the intent is classified and the state is updated. Leaving the router node, conditional edges dynamically fork the execution. If the user wants to learn about a city, they flow to the travel info agent. If they want a hotel, they flow to the booking agent. Both specialists then use direct edges to finish the workflow safely. As we wrap up, let's review best practices. Use direct transitions for linear pipelines like data extraction or final formatting. There is no need to add the latency of a logic check if the path is fixed. Reserve conditional routing for tool execution loops, error recovery, and intent-based delegation. When building your routing nodes, a crucial best practice is to force the LLM to use structured outputs like pedantic schemas. This guarantees the LLM outputs exactly the string your conditional edge mapping dictionary expects, avoiding frustrating parse errors. Finally, beware of spaghetti graphs. Keep your conditional logic modular and clean to ensure maintainability. Master these control flows, and you transition from building simple scripts to engineering enterprise-grade, autonomous multi-agent systems. I invite you all to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. See you next time. Our final mind map summarizes your edge strategy. On the top right, direct transitions provide low latency and guaranteed order for linear pipelines. On the bottom right, conditional routing enables dynamic delegation, retries, and tool loops. On the left, our best practices remind us to always use structured LLM outputs and explicit mapping dictionaries to keep our stateful workflows robust and production-ready.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by quicktechie. We have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material. So this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see this is all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have 5 practice papers paper. So click on the first practice paper. It would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now, the third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology-wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepare for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.